Okay, so function notation. So basically, function notation is just another way to write an equation that is a function. And one way that we can tell that an equation is a function is if it can be written in the form y equals something. Okay, so like y equals 3x plus 8, for example. So y equals 3x plus 8. Can you read that okay?
Yep.
Okay, so that could be replaced with function notation. Now, the most common function notation is f and then in parentheses x. But it doesn't have to be f. It could be any other letter. So basically, that is how you can rewrite an equation with function notation.
Okay.
Okay. Now, sometimes the little bit harder ones will be if it's not already in the form y equals. So a more common one was maybe one like this. See how it's an equation, but it does not have y by itself.
Mm-hmm.
So we can rearrange the equation to get y by itself. So I would first subtract 7x from both sides. So and then that would look like this, right?
Mm-hmm.
And then we would have 3y equals negative 7x plus 24, like so.
Mm-hmm.
And then next we could divide both sides by 3, because then that'll get y by itself.
Yep.
Now when we divide by 3, we divide each term by 3. Does that ring a bell?
Yep.
Okay, good. So then those 3's cancel, and we get y equals. Now, negative 7/3 would make a repeating decimal, so I'm just going to leave it as a fraction. And then 24 divided by 3 is 8. So I got y by itself.
Yep.
So now, now that I have y by itself, I can write it in function notation. So let's call this function, I don't know, you have a different letter other than f that we could use?
C.
C, awesome. So then it'll be c parentheses x instead of y, and then the rest of it will look just the same. Like so.
Mm-hmm.
And now we've written in function notation.
Okay.
So just to kind of show the whole thing again. I guess starting back. Any questions about that, or did that make sense?
That makes sense now. But then how do you do the bottom ones?
Okay, so then are you talking about the ones that are like number 5, like the graphing one? Okay.
The graphing one.
So basically, any equation can be graphed. Mm-hmm. And we can use function notation as a easy way to be plugging different x values into the function. And for every x value that you plug in, since it's a function, we'll get one y value that comes out. Yep. So the x that goes in and the y that comes out, they make a pair. And the way we write them is an ordered pair, right? X comma y. And then every ordered pair then can be put onto a position on the graph. Does that all make sense?
Yes.
Okay. So, and then if you have enough of those points, you can start to see what the image is going to look like. Maybe it's a curve. Maybe it's just a straight line. There's lots of different, shapes we can get. Does that kind of make sense?
Yeah.
Okay. So let's see here. Let me make up an example. So there's an example of a function.
Yep.
And on the homework, I give you the x values to plug in. But if you didn't have that, sometimes you just have to kind of pick values and hope that it works out. So I guess I'll plug in 3 or -3. I'll start with the negatives and I'll just kind of work my way from negatives to positive. So if I plug in -3 for an x value, let's see if I don't know if I'll have a ton of space to write this out. Maybe I'll write this on another piece of paper. So okay. So C, the function, but now if I'm going to plug 3 in it, notice how I basically remove the x and I replace it with a -3.
Yep.
Okay. One thing to really pay attention to is I have this negative sign stays on the outside of those parentheses. Okay. Because the x, the negative was outside of x, if that makes sense. So then basically we have to simplify this side, right? Because this is going to be the y value with an x value of -3. So then what is that? -3 squared is 9. But then with the negative sign on the outside, it's -9. And then -9 plus 5 is -4. Okay, so that's showing all the work of that.
Yep.
So then the ordered pair there is -3, comma, -4. Right, and then that is a point that we can plot on the graph.
Okay.
Okay, so then on the homework, I did the first one for you for each of them. But then we would, the next one probably would be we'd work our way to the right. So then we would plug in -2. So same kind of thing, but plugging in -2. Let's start off. I'm using the exact same format, right? Because it's the same function, just a new x value.
Yeah.
Okay. And then that'll be, let's see, 4 when you square it, but then the negative sign makes it -4. Plus 5 is 1. So then we ended up getting -4 plus 5 equals 1. So when we plugged in -2, we got 1. That's a point, -2, 1. So how about that? Okay. So right now I don't have, it's not real detailed. I just have 2 points. And then we keep going, right? Maybe I'll go through a little quicker this time since this is the same process.
That makes more sense.
Okay, good. So yeah, so this is what I would get for the next one.
Yep.
Okay, so -1, +4, -1, 1, 2, 3, 4. And then I can just tell you, you can plug in 0, and I know you would get 5. You can plug in 1, and I know you would get 4, 2, and I'd get 1, 3, and I'd get -4. Now they're not all symmetrical like this. Now I'm not showing the work for all these just to kind of speed up the process here a little bit, but it would be the same thing. You're plugging in those values, you get a new value out. So then in this case, I'll show you what it would look like on the graph. Oh, I missed one there. Okay. So it ends up looking like this, and you can start to see what the shape should look like. It's not a straight line here. It's an arc, right? It's a upside down. It's a parabola, technically, is what the shape is. I don't know if you remember that word.
Yeah.
But then I wouldn't just stop there because then I would connect them. And they do go on forever. So I would put arrows to show that it continues on.
Okay.
Okay. So that makes sense?
Yeah, it does.
Okay. So then if you go even further down, you were given a couple questions where the graph is given to you, but then you have to answer like what is the value of f of -8, right?
Yeah.
So here, let me make a graph. Okay. So here's a bizarre graph that I've made.
Yep.
Okay, but I tried to highlight a couple points. Now on the homework, you're not given those nice points like that. But if you look carefully, you can kind of see where the values cross. So if I say this function, I don't know, let's call it p. So if I say find, here, let's see, find p of, let's see, p of -2. Well, remember, this is function notation. So what kind of a value is -2? Is it an x or a y?
X.
An x, good. So then we're looking for where on this graph is the x value -2. And then if we're trying to find what p of -2 is equal to, we're looking for what kind of a y value. Or, okay, I just said it. We're looking for a y value. Sorry. So p of -2 is equal to some y value. So this is where the x value is 0. Right? I don't know if you can see where I'm pointing.
Yeah.
So then -1, -2. If I go up, this is the point where the x value is -2 on the graph.
Okay.
So then, well, what's the y value there? We just go over here. How high up are we? Well, I think we're up 1, 2, 3. Does that make sense?
Yes, it does.
Okay. So p of -2 is equal to 3. Right, that's how I would answer it.
Yep.
Okay. Now we can do it the other way, where it could be something like this. Let's say, well, it's still function p since I'm still using this one. P of x is equal to p of x is equal to 7. So now we have what kind of value do we know now?
The y.
The y value. And we're looking for an x value.
Yep.
So we go up 7 and we try to see where is this graph equal to 7. Well, actually, if you go up 7, it touches right there where x is 0. So that's the answer. X is equal to 0. But we actually have to be a little more careful in this case because, excuse me, there's actually another spot where the y value is 7. I don't know, can you read it well enough? Can you tell me about what another x value?
Straight across to the
Yeah, straight across. And what x value is that right there? If we go straight down, how far are we?
like a 3 or 4.
Yeah, 3 or 4. I'm gonna have to look at it more closely.
Yeah.
1, 2. It looks like a 3. So it is possible in this situation when we're looking for an x value,
Yeah.
you could get more than one right answer. So in this case, x would equal 0, but it also would equal 3. And then actually, if you look closely, like you said, straight across, I like how you said that. If we go here, straight across is up 7 still. But if we keep going, even though I didn't make a nice point, there is a spot right here that's up 7. So whatever that x value might be, let's see here. So 8 as well. So in this case, I actually have 3 different x values that answer that.
Yep.
Now I think I have only one question like that on the homework. Typically, you'll just have one answer to give, but it's possible to have more than one.
Okay.
Does that give a better idea?
Yes.
Okay.